What's going on, everybody? Boris here at your College Design Studio, and today I'm talking about bees. And I'm talking about bees because I believe it's an important issue, not just for agriculture, but for plant species and diversity throughout the United States and abroad. And something that I've noticed recently, and it's been talked about on the news and on the internet, is that the number of bees is diminishing, that colonies are disappearing, and a lot of hypotheses are being thrown around. Some say it's because of light pollution, others say it's because of monocultures, because we use bees on a consistent basis to pollinate plants like alfalfa, and that the bees are not responding well to this interference with their natural cycles. So this is a topic I'm really interested in. And on our website, there's a short research paper that we put together their college design studio. If you'd like to give it a read, the links are in the description. But in this presentation, we're going to basically examine the issue in a very quick and not very detailed manner. So just to jump right in, there's about 20,000 different species of bees, but the four main types are the bumble, carpenter, honey, and killer bees. And the paper we wrote is focusing on the honey bees. And a colony is further differentiated in three types of bees. There's the queen, the worker, and the drone. And the queen and workers are female, but only the queen is fertile. The drone is male, and their only job in the colony is to mate with the queen and produce more larvae. Uh, and the worker bees, as you can see, can be further differentiated in different categories, such as the nurse bee and the forager bee. And we're looking at a hive's behavior as determined by the genetic code of the queen. So they have a predisposition for certain functions, such as defense against hornets, pollen collection, water collection, and there's trade-offs given that genetic makeup. So, say for example, a queen is predisposed for defense but not pollen collection. That hive may survive an attack by hornets, but it may not survive the winter because they neglect pollen collection, or they neglect water collection or hive construction. We also see that the worker and drone behavior of bees is also determined by the genetic code of the queen and by uh, the oscillations in the period gene of the messenger RNA of a bee. And we also look at the honeycomb construction. So the basic idea here is to examine a beehive through the self-organizational principles that drive a colony. So how does a bee colony organize and diversify labor? How do they create the honeycomb, and why do they create the honeycomb? And the hypothesis is for energy efficiency, and that is correct. That the hexagon that the bees create is indeed one of the most efficient ways, or the most efficient way to divide a grid into equal areas. And we talked about the per mRNA oscillations, which ties into circadian cycles. You have bees that live within a colony all their not all their lives, but for the beginning of their lives. And as the per mRNA levels in their brain increase, then they begin to develop circadian cycles, and that's basically hitting upon the night and day cycles, or the ability of an insect to respond to a night and day cycle. And bees like nurser bees or construction bees, bees that maintain the colony, don't have a strong response to the night and day cycle, and that's as we expect, because if you're cooped up in a colony without seeing the light of day 24 hours a day, you don't really need an awareness of the night and day cycle. But where we do see circadian cycles in bees uh, is with the older bees, the ones that go out and forage for water and food, and that makes sense because a bee is dependent on the night and day cycles for navigation through the median air gas density. Uh, Imagine if you're a bee, you're a light insect, and you're going through. It's cooler in the morning, it's hotter in the afternoon, and then it's cooler again at night. For us, it may not matter, but for an insect, buoyancy is very important. Um, and Just think of it like this: think of it as a balloon um, that gets heavier. It's kind of hard to explain. as a balloon, it gets heavier as it grows older. So as a bee increases their age as it gets older, their mass increases as well. So there comes a point where they're no longer efficient flyers. So the older the bee is, the more inefficient it becomes. And that's because if you're a heavy bee and you're trying to fly through dense air, you're going to exert more energy. And the trade offs of you collecting a tiny amount of pollen may not be exactly efficient. And that's when we see older bees stay back farther or closer, stay back closer to the colony and perform things like hive maintenance or they secrete pheromones to control the ratio of nurse bees to worker bees, uh, and so on and so forth. And here we basically see a list of a few pheromones that bees secrete. And a son of pheromone is used for orientation. The footprint enhances the son of, and that the reason why that happens is again energy efficiency or um, minimization of energy expended. So as a bee is looking for food, or as a bee discovers food and heads in that direction, they secrete an son of pheromone. Well, the bees that come after it, that smell that pheromone and follow it, they're not going to secrete it again because that's energy inefficient. They're going to secrete something that takes less energy to generate, the footprint pheromone, and that all that does is it enhances the pheromone that's already been laid down by the first bees that discovered the water or food rich field. And we talked about the older bees secreting a pheromone that regulates the ratio of worker to nurse bees. This is how they do it. They secrete a pheromone called the forager pheromone, ethyl oleate, and it slows the maturing of nurse bees. And depending on how many bees are in a colony or what the state of the larva is at, they can either increase or decrease the rates of that, and they can mark their eggs and the larva. Brood recognition alarms for distress, and a few other ones. Um, Bees are known to self-euthanize in distress. That's not something I understand very clearly, but basically, it's not so much that it's the hive mentality, but it ties into the concept of energy minimization again. So if you trap a bee in a room and you close all the windows, the theory is that the bee is going to self-euthanize because um, it's expending energy and it's not gaining anything in return. There's no pollen, there's no water to collect, and it can't smell any of the pheromones. So in that point, it's lost. And rather than waste resources, it just self-euthanizes. And that's when we see colony collapse disorders, um, not just because of predation from birds, wasps, hornets, and spiders, and the other predators of bees, but because of human interference, things like light pollution, monoculture crops, polluted water, and so on and so forth. Um, that's not to say that the entire colony is going to self-euthanize, um, but what happens is as the colony is trying to minimize the energy expended to to gather food and water, they're finding that more and more difficult to accomplish. So as the water is becoming more polluted, or as light is interfering with their night and day cycles from nearby cities, um, the colony, in a sense, and I'm not sure if this is exactly what happens, so don't quote me on it, but the colony is realizing that the energy expended for food collection and water collection does not equal or exceed the energy derived from those activities. So it becomes impractical to continue that activity, and because they can't migrate or they can't survive. Bees live a very short life. I think it's like a month. A bee can from birth to death, a bee can expect to live about 28 to 30 days. With foraging present, I believe it's from day 22 to day 28, um, and things like that. So the colony collapses because of imbalances in the energy efficiency um, of their operations. Uh, and there was a honeycomb conjecture. It's called the Kelvin problem. It basically deals with the surface minimization of space. It basically holds that any partition of a plane in regions of equal area has a perimeter at least that of the regular hexagonal honeycomb tiling. meaning that a hexagonal grid is the best or most efficient way to divide a surface into regions of equal area with the least total perimeter. And equality is attained if this thing here on the bottom, if and only if P is a regular hexagon of area 1, where T is the region of the honeycomb tile, K is a disk of radius P, sigma alpha, which is not on here, is the number or area of the hexagonal tiles contained entirely in the plot. And P is the region, N is the number of sides in a polygon, and NP is the number of directed edges bounding the region. So that would be this here. So basically, to make the long story short, basically what they found out was that the bees really do create hexagonal structures because mathematically that is the most energy efficient method, or the most efficient method of dividing a regular grid area into equal areas with a minimum perimeter, and that's hexagons. Whether that's because of the genetic disposition of the bees, or it's because of exactly why they do it, I can't answer that question myself. I just know that that is the most efficient way, and that's what they do. And when we see things like colony collapse disorder or the disappearance of bees across the United States, Europe, and the world, we're seeing an increasing risk of not being able to pollinate our crops and losing even more diversity than we have already lost, because it would be very difficult, if not impractical, or if not impossible, to do that task ourselves. That's why we rely on bees. And it's pretty interesting. You can see them ship bees across the states in huge trucks, and they bring them to a field that needs pollinating, and they let them pollinate. But one of the theories is that this kind of interference, because they can't get their bearings, and because if you're cooped up in a truck, you're basically cooped up in the hive. You might as well be, because there's no sunlight, and the older bees that depend on circadian cycles, the night and day cycles, are not able to regulate their behavior, are not able to use energy in the most efficient method, and that leads to things like, when we looked at the pheromones, it leads them to incorrectly secrete the wrong pheromone or the wrong amount of pheromone to regulate the ratio of workers to nurses. And these imbalances and these disturbances are probably what contributes to the declining beehive colonies. So anyways, I've talked your ear off. That's all I've got for this. Again, the paper is, the link to the paper is, it's a PDF document. It's pretty short. It's in the link of this description. And let me know what you think in the comments below. Do you agree? Do you disagree with some of these findings or some of these hypotheses? Or what do you think? Do you have any experience with bees yourself? When I was younger, my grandfather had, and he still does have, several bee colonies, but he doesn't ship them. He's a traditional farmer. He uses them for honey. He just likes honey. So he raises them. I think he's got 10 right now. And that was my first introduction to bees, and I think it's fascinating. I walked out, no protection, no nets or anything like that. I thought I was gonna get stung, but I didn't, thankfully. But I personally love bees. I find them very interesting, just their behavior and the product that they create. I love honey too. I drink it with milk and everything. But enough about that. Yeah, let me know what you think. Do you think bees are disappearing, and if so, why? Do you have any theories? Do you have any personal experiences with that? And if you have any questions, let me know. Thanks for watching, and I'll see you next time on an Ecology Designs production.